Hi everyone, welcome back to the Sun Devil Learning Lab. My name is Miss Alfred, and today we are going to be talking about finding the volume for 3D shapes and particularly cylinders. So with that, let's get started. All right. Okay, so before we get started, actually, if you have a pencil or a piece of paper you might want to take notes on, or a notebook that you've been taking notes on, feel free to pull those out right now so you can take notes or jot stuff down, or maybe just like copy down the examples. And then also, if you want to use a calculator, you can at any point and have that next to you if you want to use it. So the objective for today is I can use the formula for volume to find the volume of a cylinder. So like I said, we're going to touch on what volume is, look at two different 3D shapes, and also be finding the volume in word problems too. So what is volume? Well, volume is the space that a three-dimensional figure can occupy, so that it takes up the space that it takes up. For example, the volume of a glass is the amount of liquid it can hold. So if you think of a glass, maybe you have one at home or you have one sitting next to you or your computer, you have a glass of water. The volume of the glass is going to be how much liquid you can put inside of it. And the volume of a solid, so like I said, a solid, two-dimensional, three-dimensional is always going to be a number greater than or equal to 0. So a two-dimensional shapes, they're not, they don't have volume with that. Whereas, a three-dimensional object has, it's 3D. It's has sides to it, and it's like a cup you can pour water into. Maybe it's a box so you can put things in it. Maybe it's a cone. So those are always going to have, maybe it's a really small volume, or maybe it's a really big tank and it holds lots of different things, so it has a very big volume. But if it's a two-dimensional shape and it's flat, it's not going to have any volume because there's nothing that can fit inside of it, whether that's air, that's food, or water. So the formula for the volume of a rectangular prism is V equals length times width times height. So we know, this has been ingrained in your mind, that area equals, for a rectangle, length times width. You know that. Area equals length times width for squares and for rectangles. Okay, so we see a rectangle right here. We see a rectangle right there. Well, when it comes to three-dimensional shapes, when we find the volume, we find the volume of all sides of the shape. So we do have a length and we do have a width, but since it's a 3D shape now and it's not just flat, we have a height. So when we find the volume of these 3D shapes, we're finding the volume for these three different sides. It's the same thing goes for this cube, like a Rubik's Cube, or this this cylinder, which is what we're going to be paying attention to and looking more closely at throughout the lesson. And then also cones. So first off, write an equation to determine the volume of this rectangular prism shown. So we have, we know that our volume equals length times width times height. You don't have to solve for anything, you just have to write out an equation. So what might this look like? We have all of our sides that are labeled. We have a length that's labeled at 6 centimeters, a width that's labeled at 4 centimeters, and a height that isn't labeled. It just has the variable h. So we are going to keep that variable h. So let's plug all those numbers in. Like I said, length is 6, width is 4, and our height is still h because we don't know it. But let's multiply together the numbers we do have. 6 times 4 is 24. Well, we are just going to keep our variable there, and if we are multiplying by a variable, the variable just stays with the whole number and is included in the answer. So our volume is going to equal 24H centimeters cubed. So centimeters is our units, because that's what they have here. And then cubed because it is a three-dimensional shape and we're talking about volume. So this is basically the same thing as saying our volume is going to equal the area of the base times our height. Well, didn't we do that? We know that when we find the area of our rectangle, it's 6 times 4. Okay, we found the area of our base. This one's like more of a cube of a square, but it's the same concept. Oh no, because it has different sides. Yeah, sorry. Forget everything I just said. But so we have our rectangular prism. We know we multiply our length and our width to get the area of the base, which is the rectangle. Well, then we have our area of the base, and now we multiply it by the height. So we could also say for a rectangular prism that volume equals the base, the area of the base, times the height. So we are going to be looking at cylinders throughout the rest of this lesson. Before we start on cylinders, I just want to kind of refresh in our minds circles and finding the diameter and the radius. So the diameter, we have two big circles. These are the same size circles. The diameter is going to be the length from one side of the circle to directly across to the other side of the circle, which is in this case 10 inches. So it's going to be the same for any side we touch from that is directly across from each other. So the diameter, one side of the circle to the side directly across. So the length basically of the circle, and that's also called the diameter. Well, the radius, on the other hand, is going to be half of the circle. So if you put a point in the middle of our circle and we draw a line to any point on the circle, then that is our radius. You could do this here, you could do this at any point, and the radius is going to stay the same. Well, the radius is also just half of the diameter. So it's important that you might get problems that tell you the diameter. You might get something where it says the diameter is 10 inches, and you need to be able to see, okay, this is the diameter. Are they asking for the diameter, or are they asking for the radius? Do I need to take the diameter and divide it by 2? Or what is it kind of that they're asking for? So make sure you're paying close attention to that. But we're going to mainly be using the radius. In this case, this radius is 5 inches, which is also just half of 10 inches. And like we said, it's gonna just be half of the circle. So to find the area of a circle, you most definitely know this, but just a refresher, area is going to equal pi r squared. So in this case, when we're finding the area of a circle, we're looking at the radius only. This is the equation we're going to use every single time. So area equals pi r squared. If we're given the diameter, we need to cut that diameter in half and just use the radius to figure out our area. So in this case, our radius is 5, so 5 squared is 25. So our area would equal 25 pi. Okay, so now that we've talked about the rectangular prism and a little bit about like radius, diameter, and circles, finding the area of the circle, based on what we know and how we solve to find the volume of a rectangular prism, now write an equation to determine the volume of the cylinder. So think a little bit about how we said that the volume of the three-dimensional shape we were just looking at, the rectangular prism, was the base, with the area of the base times the height. So in this case, if we found the area of the circle, which is the circle is the base, and we multiplied it by the height, I think that might give us the volume. Oh, go back. So we know how to find the area of the base. We have our area equals pi r squared. What's our R? What's our radius? Well, here they give us our radius. It's 4 centimeters. So we plug our 4 in for R, and 4 squared is 16. 16 times pi is 16 pi. So we know the area of our base is 16 pi. Well, we're still working with variables here, but we know that our volume is going to equal the area of our base times our height. So we just plugged those in. What did we get? We had 16 pi, right? And now we include this h. So our volume equals 16 pi times h. That is the equation we would use to find the volume. If we were given our height, if they wrote an actual number, then we would write the computation, we would write it out, and we would have more of an answer. But in this case, we're just finding out the equation. So we're going to talk a little bit more about these formulas for volume. So we talked and said that for rectangular prisms, volume equals length times width times height. And we also said that volume equals the area of the base times the height. So we have this blue base, this blue rectangle. That's our area of the base times our height. Well, now we worked with a problem that worked with finding the equation for a cylinder. And I don't know if you can see, but between these two lines, there's a big B for base. This circle is our base. For a right cylinder, our equation is volume equals pi r squared, which is also the same thing as the area of a circle, times our height. We need to know the radius of the base and the height of the cylinder in order to figure out the volume. But this in particular is a right cylinder, and this is what the only type of cylinder we're going to be looking at throughout this lesson. But it's a right cylinder because the sides of the cylinder connect to the base, making a 90-degree angle. So, and that's at any point. So if you see all these lines, it would be like this is the side of the cylinder and this is where it touches. So that the angle is always going to be 90 degrees, making it a right cylinder. Okay, so now let's talk about some cylinders in the real world. Maybe you are some of these are coming to your mind as we are speaking about them, or you're just like paying attention to the shape. Maybe you can think of just things around your house that might be a cylinder, but we had cans of food that are cylinders. We have a glass of water. That's a cylinder. These are all the 90-degree right cylinders. You see pretty much a right angle. We have power plants that are in the shapes of cylinders. And we have glass beakers right here, this one. That's a cylinder, glass beaker for science. So although we might not make the connections all the time, we deal with cylinders probably every single day. And there's people who work, and maybe they work at this power plant and they have to measure volume, or they have to figure out certain things that deal with how much can fit inside of the cylinders. So it's not just we're figuring out volume to write an answer. This kind of gives us an idea of how much fits in here and what can this tell us. So what does volume tell us? That's the biggest question, I think. Volume is the space that a three-dimensional figure can occupy. So the volume of a glass is the amount of liquid it can hold. Like we said, you have a glass, like that glass of water, it's the amount of water that can fit in there. Or the amount of food or liquid a can can hold. So we had that can of food. Maybe it's the amount of food we can fit in there. That's the volume, the amount of stuff we can put in there. Imagine the water inside of a tank. How much water can fit inside of a big tank? That tank is going to have a lot of volume. Or the cereal inside of a cereal box. How much cereal can we fit in there? What's the volume of the cereal box to determine how much cereal we can fit in there? Or the amount of chemicals or liquids a science beaker can hold. All of these have different, they're different sizes, they have different volumes. It's important to be able to identify these shapes in the real world and understand how a simple math computation can help and or tell us so much. So there's people who work these with these shapes every single day, and they find the volumes to figure out how much food do we package in these cans, how much whatever it is we're working with, how much of it can we stick or can we fit into these big cylinders, how much water are we packing into these things, or how much maybe a scientist is going to be very particular about the beaker they get because they need to be able to put a certain amount of liquid or a science chemical in there. So it's important to understand and identify the shapes and how volume plays a big role, because it can tell us so much, and it does tell us so much for a lot of people. So let's do an example together. So we have a right cylinder here. We know that it has a radius of 2 centimeters and a height of 5.3 centimeters, and we're going to find the volume. So like we said, the radius is 2 centimeters. So first thing we have to do is find the area of the base. And once we find the area of the base, we can then use that to figure out the volume. So although it tells us a centimeter up the top, obviously they're going to be the same because it's a right cylinder, and what's true for one base is going to be true for the top. So our equation for area is A equals pi r squared. So what's our r? 2. So pi times 2 squared. 2 squared is 4. So our area is 4 pi. What is the height? Like we said, it's 5.3 centimeters. And it is important to pay very close attention to the units that are being used, because when we want to mark our answers correct of the units, so make sure you're paying close attention that you are using the right units and also marking as squared or cubed, especially for volume. So we have our area of the base, which is 4 pi, our height 5.3. So we know what to do at that point. What's the volume of the right cylinder? Well, it's the area of the base times the height. So we have our 4 pi times our height, which is 5.3. 4 times 5.3 is 21.2, and we have our pi here, and we're just going to bring it down. So the pi also, you know this, equals 3.14. And you can either keep your answers in terms of pi, which is what we're doing, or we could multiply our answer by 3.14 and get an exact, or round up to like the first or second decimal. So let's do 21.2 times 3.14, and our answer is 66.568. So we would just round it to 66.57 centimeters cubed. You could do that. There's going to be maybe questions that ask you to give it in terms of pi, and other times they might ask you to just estimate. So then in that case, you're going to multiply your answer by pi. So if you chose to maybe pause this video and do this on your own, or the examples that we continue to work on, if you want to go ahead and multiply the answer by pi to get, you know, a more exact volume, then feel free to do so. You are definitely going to get a different answer, but as long as your in terms of pi is the same as mine, then that is a-okay. So now it is your turn. You're going to try this problem on your own. So what is the radius? And once you find the radius, can you find the area of the base? So I just want to point out that we are given the diameter here. So we've talked about in this lesson so far what to do when you have the diameter and what you need to do to get the radius and the difference between the two. So take a second to find the area of the base, figure out the height, and maybe you pause the video and figure out the volume of the right cylinder on your own. You know the equation. Once you have your radius, you know the height, find the area of the base, and plug those numbers in. You can keep it in terms of pi if you want. And if you don't want to, go ahead and multiply the answer you get by 3.14. But don't forget that centimeters cubed or inches cubed. See, this is where I went wrong. Inches cubed. Okay. I'm gonna move myself over here. Okay, so the radius of the base is 6. Our diameter is 12. Diameter cut in half is 6. The area of the base is pi r squared, so pi times 6 squared. 6 squared is 36. And 36 pi is the area of the base. What is the height? 25 inches. So what is the volume of the right cylinder? Well, we have our 36 pi, which is the area of the base, times our height. Multiply 36 and 25, we get 900, and we just bring over our pi. If you chose to write an estimate, let's see, it would be, I'm going to do that one more time, 900 times 3.14, which is 2,826 inches cubed. So whichever way you got it, either way is correct. And if you just prefer to not have pi in your answer, then feel free to go ahead and multiply that out. So now we're going to work on a word problem. So we know how to find the volume of a cylinder when we know the height and when we know the radius. We can easily figure out the volume. Well, now we need to kind of put this into like a real world problem and like in context, maybe a word problem. So it says a cylindrical tank with dimensions showed below contains water that is 1 foot deep. If water is poured into the tank at a constant rate of 20 feet cubed per minute for 20 minutes, will the tank overflow? Use 3.14 to estimate pi. So this question is telling us, first off, that they want the answer to not be in terms of pi. So whatever we get, we're going to multiply by 3.14, and we're probably going to round to the second decimal. So here's our cylindrical tank where we have a radius of 3 and a height of 12. And then this is where the water that's already in here is at. And it says that the water is 1 foot deep. So the height of the water is 1 foot, but the height of the entire tank is 12 feet. And that is our unit. So let's find the volume of the tank. That's what we're going to do. So we can start this problem. We want to know, I'll go back. Let's see. We want to know if water is poured into the tank at a constant rate of 20 feet cubed per minute for 20 minutes, will the tank overflow? Because of how much water is already in here. So first we'll find the volume of the tank, of the big tank. The radius of 3 and a height of 12. Well, we know we'll plug those numbers into our area equation. And 3 squared is 9. 9 times pi is 9 pi. So 9 pi feet squared for our area. Now that we know that, we can take that, plug into our volume formula. V equals 9 pi times 12, because 12 is our height. 9 times 12 is 108. And we need to multiply that by pi, so 108 pi feet cubed. When I did this already, where I multiplied 108 by pi, 3.14, and I got 339.12 feet cubed. So that is our volume of the entire tank, 339.12 feet cubed. Okay, so we have that noted. Now we want to find the volume of the water that's already in the tank, because if we figure out how much water is already in the tank and subtract that from how big the tank is and the volume of the entire tank, then we can figure out how much water can fit in there, and if we can continue to fill 20 feet cubed per minute for 20 minutes without it overflowing. So what is the area of the base? Well, our radius is still the same. So 3 squared, 9 pi feet squared. Well, our height is different. So when we're looking for the volume, we're going to take the 9 pi, which is the area of the base, and multiply that by 1, our height. 9 times 1 is 9. Multiply that by pi. 9 pi feet cubed equals 28.26 feet cubed. So when I took 9, multiplied it by that pi, 3.14, and I got 28.26. That is the volume of the water that's already in the tank. So now that we know that, we know the volume of the tank total is 3.39. And, oh, I am so sorry. The volume of the water in the tank is 28.26 feet cubed. So we have what the big tank is overall, the volume, and how much is already filling it up. So the thing we're going to do is we're going to subtract 339.12 feet cubed minus the water that's in the tank. And we get 310.86 feet cubed that's still left over. So that's from the top of the water to the top of the tank. So that's how much water we can fit into the tank still. And if it's more than that, it overfills. If it's less than that, then it can fit. So if the water is poured at a constant rate of 20 feet cubed per minute for 20 minutes, then that would look like 20 times 20 to get 400 feet cubed. So if that were to be the case, water was poured for 20 minutes at a constant rate of 20 feet cubed per minute, with knowing that the water is already here in the tank, the water poured into the tank would overfill it. So if it was less than 310, it wouldn't overfill it. But since it's 400, the volume, the amount of water that would fill up the tank for 20 minutes at that constant rate would be 400 feet cubed, which is about 90 feet cubed more than we can have in the tank. Therefore, if the water is poured into the tank, it would overfill. So that is like the idea of that. That could be a real world problem. You think about these people who work with water tanks and stuff, they have to consider these numbers. How much water can pour into there and how quickly, at what rate, how many feet per minute. These are things that, it might just be a simple word problem that we're working on here, but to somebody else, this could be a real world problem. These are the calculations they're doing or thinking about on a day-to-day basis. And that's what's important. So what does volume tell us? Well, volume tells us how much of something can fit into that three-dimensional object. Like if you have a glass, how much water can fit in there? How much of something can occupy that space? That is volume. And it can tell us a lot more than just an answer. It can tell us things we're working with, things we need to consider, things that we need to we need to change. Volume helps us make adjustments. It helps us to understand different maybe problems that we're dealing with, or give us a better idea of, like I said, things that we need to change or that we're dealing with on maybe a day-to-day basis. Or maybe we're not. Maybe you're in science class and you're working with certain chemicals and you need to know how much fills a beaker, or those sorts of things. So it's so much more than just a number, and that's what's important to understand. What is the equation for the volume of a cylinder? This is the question of this entire lesson. We know what volume tells us. It tells us a lot more than just a number. But what does the equation for volume, what is it? Well, volume equals the base of the cylinder times the height. And the base of a cylinder is the area of a circle. So the area of a circle equals pi r squared. That is in parentheses, and then we have our height. So pi r squared times our height. That is the equation for volume. So I have linked some resources here if you want to pause the video, maybe, I don't know, jot these down. But at the same time, we have the learning guide that's also attached to the YouTube video. So feel free to hop on there and get some more practice in, maybe work on some word problems, or if you want to get ahead and start looking at some stuff maybe we'll look at this week, feel free to do that too. But I hope you guys enjoyed this video. I hope that you were able to take a lot away. Feel free to go back through and pause the video at any point and just jot down some notes, or any of these shapes. Get really familiar with them, because volume is going to be something you'll see for a while from here on out. So again, thank you guys so much and have a great day.